Hello and welcome to Gaffy's Grinds. My name is Mr. Gaffy and I'm a science teacher trying to help you understand some of the more difficult concepts in junior cert science. So in these short videos, we'll be taking difficult concepts and breaking them down, trying to help you understand them a little bit better, then doing some practice questions on them topics. Some general tips for watching these videos are, if you've got your mobile phone, it's a good idea to turn it off or put it in a different room, and just so that it's not going to distract you. Do not have other tabs open on your computer or your iPad. Again, if you get a notification or it makes noise or you get tempted, you get distracted, and it stops you from learning. And then the really important thing is I'm going to be giving you tasks to do, questions to answer. When I ask you to do them, you should try your best and do them. Okay, if you don't, you're not going to learn. So you're pretty much wasting your time if you don't do the questions. So for today's topic, we're going to be looking at heating curves. In particular, we're looking to explain them, to describe what's happening at each step, and to explain what happens when something melts or boils. So this here is a heating curve. Okay, so when energy is added to a substance, and we will hear more about energy at a later date, its temperature increases. That's what this graph shows. On the x-axis, we have the addition of heat. So going on the x-axis, we have increasing from 0 amount of heat up to more heat. We're not sure, we don't have any numbers on this, it's just a general graph. But we know we're starting at 0 and it's increasing. So the number line increases on the x-axis. On the y-axis, we see temperature increases. So it begins at 0 down here, and it goes up or increases along the y-axis. Okay, so if we were to describe this graph, we see that it starts at A and it's got letters along it at different stages. So what we're going to do is slowly start and go through it. So at A, its temperature is at its coldest. So the substance is at its coolest here. It's got the lowest temperature. And you notice that this is also the stage that the least amount of heat has been added. Now, the first part of the graph that we see is a sloped line upwards. It's slowly increasing, so it's going up. Okay. So temperature is rising. Okay, so temperature is rising or increasing. Now, if this is a substance at its coldest, it must be a solid at this point. The temperature is a solid and its temperature is rising between A and B. Something strange happens when we get to B. Between B and C, heat is still being added because we are moving this way along the x-axis. Heat is still being added. The temperature has stopped going up. This is because the heat that is being added at this stage is not being used to increase the temperature. Instead, it needs to be used to separate the forces of attraction between the particles. So if we draw our particle diagram really quickly, we know our solid has particles arranged in neat rows, all touching each other. And we know that they are held tightly together because they have strong forces of attraction between them. To turn it into a liquid, they're not held as tightly together in rows anymore. And this is because the forces of attraction between them have been weakened. They're not as strong as they used to be. So the energy involved between B and C is being used to break the forces of attraction. So during this time, the graph stays flat. We've got this flat portion of the graph, and this is heat being used to break forces of attraction instead of changing the temperature. There is a name for this type of heat. This is called latent heat. So heat used to break the forces of attraction instead of increasing the temperature, latent heat. We then see the graph begins to increase in temperature again. So this between C and D, the graph increases in temperature again, just like it did there. The difference is that during this phase, we're now a liquid. We're a liquid increasing in temperature. Okay, now, so at this point, energy is still being added. Temperature is increasing. Once we get to D, we see another flat part of the graph. Okay, so this is another stage of latent heat. Energy is being used instead of increasing the temperature, it's being used again to break the forces of attraction, make them even weaker. So now the forces of attraction are completely broken. These particles are free to move wherever they want. Okay. Following that, between E and F, we're now at the stage where the substance is at its hottest. It's got its highest amount of energy, and its temperature is the highest out of all the letters here. And between E and F, we have the temperature rising again. Now, if we were to try and say what was happening at each point, just to summarize, between A and B, we have temperature increasing or heating. Between B and C, we have a change of state. Latent heat is being used to break the forces of attraction between the particles, and the state is changing. So this is going from a solid to a liquid. This is melting. Melting. So between B and C, melting. Sorry, this pen doesn't want to do what I'm asking it to do. Melting. Then we've got another period of heating, and between D and E, we've got another change of state. So between D and E, got latent heat, no change in temperature, and we are now boiling. Now, it is a bit more complicated than this. We're just keeping it nice and simple, and it's even more complicated if we're to look at a cooling curve. But for now, this is all we need to know. Okay, so I've got some questions for you guys to practice now. I will show you how to do the first one. Okay, so 58 says between which letters is melting taking place? So on the graph, I can see that between B and C, the temperature has stopped changing. We've got the flat part of the graph. That means the forces of attraction are being broken and a state change is happening. So this is melting, changing from a solid to a liquid. Melting. Okay. So you guys should be able to answer the rest of these questions now in your practice copy, 59 down to 65. If you have the booklet, if you're in my class and you have the booklet, these are the same numbered questions in the booklet, 59 to 65. If not, if you're not in my class, then it's okay. You can just use the same numbers in your own practice booklet or your workbook, wherever you're going to do your questions. Okay, so I'm going to get you to pause the video and try these questions now. Okay, now you should only be watching this video if you've paused the question, if you've paused the video and done all the questions. I'm going to show the answers now, so just make sure that you have tried the questions. Again, I'll just remind you, there is no point in watching these videos if you're not going to do the questions, because you're not going to learn anything. Okay, so I'm going to put the answers onto the next page now. There they are. Question 58, we did already. 59, at which letter does boiling start to take place? And that was at E. Apologies, that's a mistake. Just going to go back here. That should be D. That's a mistake. So 59, boiling starts to take place at D. It finishes at E. Apologies. Question 60 says, at which letter is the substance at its hottest? That is the last point, so it's F. At which letter is the substance at its coldest? Well, that's at the first point. When it's at the lowest, it's A. Between which letters is the substance a liquid and it's starting to heat up? So between C and D, it's a liquid and it's starting to heat up. But 63, between which letters is the substance a solid and starting to heat up? That's A and B. In the beginning, it's a solid, starts to heat up between A and B. And finally, 64, between which letters is the substance a gas and starting to heat up? It's the last two, E and F. And at which letters do strong forces of attraction get broken? Well, strong forces of attraction are present in solids. So at which letter do forces of attraction start to get broken? Well, that's when it starts to go from a solid to a liquid, or when it starts to melt. So it will be at letter B. Okay, well done if you got all those right. That means now that you are able to describe a heating curve and explain what happens at the melting point and the boiling point. So well done if you got that right. And thank you for tuning in. I look forward to seeing you again.